Okay, so the idea here is that if you approach 2 from the right side or from numbers bigger than 2, then your y value, if you're squaring those numbers, gets closer and closer to 4. And if you approach it from the left side or numbers smaller than 2, then the value of your function gets closer and closer to 4. And that's because the function's value at 2 is actually 4. Now, if you're wondering, okay, if I know I know what the function is when x is 2, it's 4, okay? What's the point of this limit stuff? In order for you to have some kind of a feeling for what a limit is, suppose everybody in here decided they're going to train for the next Boston Marathon. Okay? You're going to run the next Boston Marathon. So what are you going to do to get ready? You're going to run, right? Now, if you're running a marathon, do you want to be able to run as fast as you can for the whole time? Well, you do, but you also don't want to, charge off like you're doing a 50-yard dash, because you're not going to last very long. So yeah, you're going to try to get to a good speed, but you're also going to try to pace yourself a little bit. But let's say you do start out trying to build your endurance using a 50-yard dash. What do you suppose your time would be for a 50-yard dash right now? Just a guess. Anybody? I know what mine would be, but probably like 10 minutes. No, it wouldn't be that bad. 50 yards. That's a 50-yard dash is pretty much from that end of the hall to the other end of the hall, running as hard as you can. Well, let's go with a 40-yard dash. Five flat, okay? That's 5 seconds, not 5 minutes, right? Okay. If you started out, and I assume when you were doing your 40-yard dash, you were probably in, you've been running and you were in good shape, right? That's your best time ever?
4:09.
Okay. So, do you suppose he did that the first day out? Do you suppose if you were to run from one end of the hall to the other just today, one time, do you suppose that you would do your best time the very first day? No, because most of us are not ready for that right now. We're not trained. What if you ran that hallway 3 times a day, every day, for the next 6 months? What's going to happen? Your time would get better. You'd get better and better. What if you ran up and down that hallway 10 times a day, every day, for the next 6 months? You would get even better and better. Would you ever be able to run the length of that hallway in 1 second? Not happening. You'd have to be able to teleport practically to be able to do that. So what happens then, you get better and better and better, but do you ever get to the point that you're not going to get any better? What do you call that when you reach that point that you can't improve anymore? That's a limit, okay? So a limit is the idea that you get really close to something, but you don't actually get past it. In fact, you don't even actually get to it. You get really, really close to it. So try to think of it that way. And then as we get further into why we're talking about limits, it'll start to make more sense to you.
Is this correlated at all with asymptotes, like that type of idea?
Yes.
Okay.
Yes.
I recognize that.
And in fact, we're actually going to come up on an example here in a minute where we're going to talk at, what is the limit of this asymptote. Okay? Yeah, that's a good question. So we looked at it numerically. Excuse me. Oh, okay, I know what I'm doing now. On yours, you should be able to look at the table that hopefully you are seeing, because I'm seeing my teacher version. You should have just been seeing this table, and it's asking you to draw it. Okay? Now, even if you're on the computer, you can draw it. Okay? Even if you're on the computer, you can draw it. I'll show you how I know you can. I'm gonna go to the other one where I logged in. And this is what you're seeing. Use the table of values to estimate the limit as x approaches 1 of f of x. And I'm looking, x is going 0.9, 0.99, 0.999, and so forth. What value would be right here?
One.
X equals 1. What is f of x approaching from either side as I get closer and closer to 1? What's the value of f of x getting closer and closer to? 4. So I'm going to go down here and I'm going to get a pencil. And I'm going to use red. And there's my answer. So even if you're on the computer, you can do this. Now you'll notice there's also text boxes and erasers and stuff down here, and that's fine. If you wanted to type it in, then you can type in here x or f of x equals 4. And I don't think mine's working, but that's okay. I kind of like drawing on them better anyway. Okay? So now I'm going to go back to my teacher one. And this is why I told you you didn't have to use your real name. I'm waiting to see what y'all put. Put an answer. Now, probably from where you're sitting, unless you just recognize yours, you don't know what everybody else is answering. If I were in class, I wouldn't show you this screen ordinarily, but I want you to know why I'm using this. Normally what I do is I log in as a student on the computer, and then I have my iPad in my hand, and I run it from my iPad so that I collect the data. So I may give you a real quiz in your pod. I may ask you to actually answer questions in your pod, but that lets me know, we've been doing these 3 problems, now you do one. Let me see if you can do one. And then I don't necessarily show everybody that one. I may show somebody a representatively good answer, but it won't show whose it is. Still waiting on some. Now, I guess I'm still waiting on mine, actually, because mine apparently I did. Okay, after you've put your answer in, put send. You may have answered, but until you actually click send, I won't see your answer. Okay, so mine's showing now. So, where's Brandon? Draw your answer. You did? All right, hit send.
Oh, I had it on my iPad, then I changed it back onto the computer.
Oh, okay.
So I've got 2 on there.
Oh, you got 2 on there. Okay, that's fine.
Sorry.
As long as everybody knows how to do it. That's the only thing I want to make sure is everybody knows how to do it. Because I'll use Nearpod for in-class some too. Okay, so now we're going to move on. At that point, I don't know everybody knows how to do a limit by looking at a table. Now, the other thing we looked at is you could do the same thing on a graph. What we're doing with the red arrows, we're sneaking up on 2 and finding that as we sneak up on 2, we're getting closer and closer to 4. And if we come from the other side, we see that as we sneak up on 2, we get closer and closer to 4. So this is called a two-sided limit. This means that as you're approaching from both sides, when you're approaching from the right, we write it, the limit as x approaches 2 from the positive side. And when we approach it from the left, we say that it is the limit as x approaches 2 from the negative side of f of x is 4. So this is pretty much where we wound up talking about, what, this is the formal mathy definition of a limit. The idea of a limit is that you're trying to sneak up on x and figure out what its y partner is, without actually coming out and asking, if you want to think of it that way. So here's a graph. What's the limit as x approaches 3? And again, this is just a number. So as x approaches 3, from the left, looks like y is getting pretty close to 3. And as x approaches 3 from the right, looks like it's getting pretty close to 3. So I think the limit as x approaches 3 of f of x, without even knowing what f of x's equation is, I think the limit is 3. Does that make sense to everybody? I see some folks that have a really good way of doing it. Some people are just answering the question, and that's okay too. Okay, now in the interest of time, because we do want to get to some new stuff, the definition of a limit describes what happens to f of x when x is near but not equal to the value of a. It's not affected by how or even whether f of a is defined. So for example here, and I think we did this one in class, if you look at it numerically, what you find out is that you can't put x equals 2 into that function. Because if you do, that function has a hole, which we looked at that hole graphically, and then we figured out, we also made the table, but then algebraically we factored and simplified that function and found out that its behavior is the same as x squared, as long as we don't let x be equal to 2. And we actually graphed it and saw the hole in the function. So there's 3 ways, basically, we learned last time, to find a limit algebraically by trying to simplify the function. Using graph, either drawn by hand or with a graphing calculator, and you can use your trace button with the graphing calculator to try to find your limit. Or you can use a table that you make by hand, which I don't recommend, or on the graphing calculator. Find the limit of this function. And this time I'm not going to participate. I want you to find it. Find the limit as x approaches 2. Because this is going to tell me if everybody's got it.
Is that actually right?
Mm-hmm. f of x is not defined at x equals 2, but the limit is defined. You can take the limit from the left and the right. As you approach 2 from the negative side, what value of the function does it approach? And as you approach 2 from numbers more than 2, what value does it appear that f of x is trying to get to? Now, I see some answers coming. I can see them on my screen. You probably can't, because it kind of blacks out the rest of the screen while I have that up here. These got it. Brandon's got it. Looks like most of you have it. So the limit is 4. But is f of 2 equal to 4? No, because there's a hole at x equals 2. See, and I think I actually got everybody. I think I've got everybody but Seth and me. I'm not worried about mine. So as long as everybody's got it. Okay. Determine the limit h of x for the function h defined by this, and this is a piecewise function. Okay? Notice that it's approaching 2. So if x is actually equal to 2, f of 2 or h of 2 is actually 1. But if it's more than 2 or less than 2, then whatever the number is going to be x squared. So if you were to get your calculator, we'll just do this one numerically. And I'm not going to use the whole function because I don't need that second piece. I'm going to use the x squared part. So I'm trying to come at it from numbers less than 2, so I'm going to do 1.9, 1.99, 1.999, 1.9999. What's it getting close to? 4. How about if I come from the other side? What's it getting close to? 4. So the limit as x approaches 2 for h of x is going to be 4. Okay? Even though h of 2 is actually 1. Can this function actually take on the value -2 for x? No, because it's going to make a 0 in the denominator. So what we have to do then is we're going to enter in that function And then I'm gonna make sure that it's not connected because I wanna see just the points. So I'm gonna go to second mode. I'm sorry, just mode. Make sure I'm set to dot. And then I'm gonna go to zoom. And I'm gonna choose decimal. Okay? Zoom decimal.
Why would it be it's giving me like an error message, but I have my windows, they're not like weird or anything, and I have the equations in writing, it's giving me this error.
Oh, okay, I know why it's so easy if I just show you. That's still on. Put your cursor on it, press enter, and it turns it off. Now, there you go. Yeah.
Thank you.
If you've been using your stack plots, they have to be off if you switch to graphic.
Oh, okay.
Yes.
But H2 is.
It's actually one. You actually have it not connected to the box, which is kind of the same thing that I'm saying.
Yeah.
Yeah, it is, because it's only showing just the specific points. You have it right to do that. You may have to do it all. So when you look at your graph, tell me what do you think? Just trace on the graph. Trace on the graph. What happens if you try to approach, -2, let's say from this side, from the positive side of -2, from numbers greater than -2. When you trace, what's happening to y as you get closer and closer and closer to -2? Whoops, it disappeared because I hit -2. What's it getting closer and closer to? Is it getting closer and closer to a single number? What's it actually doing? Let's go look at the table. I'm trying to approach -2 from numbers bigger than -2, so let's start at -2.1. Then -2.01. -2.001. -2.123, 4 zeros. Oh wait, no, only 3. Let's just do 3 and a 1. Is this, what's happening to y? It's not approaching a single number. What's it doing? It's getting bigger and bigger and bigger and bigger and bigger, right? This is one of those cases where I can go, even though that says -2, I can go down here and go -2.1234, -2.12345. Now the number's so big it has to go to scientific notation. So So as I get closer and closer to 2, the number is getting closer and closer and closer to positive infinity, right?
Well, I'm gonna put in -2.00001 instead of errors.
You see.
Oh, it didn't let me.
Yeah. But you don't even have to keep going with more and more decimals to see what's happening to y. Y is increasing by about a factor of 10 every time, right? And if I try to approach from the other side, same thing happens. And this is actually, let's see, negative 2.1 is actually further down the scale. So if I go from negative 1.9 and then negative 1.99, negative 1.999, negative 1.12349s, what's happening now? Those numbers are all negative. They're still getting more and more and more and more and more negative, right? What does that graph seem to be doing? What's going on with this graph as I approach negative 2 from the left? Where's the y going? It's going to infinity. And if I approach from the right, it's going to negative infinity. We say that this is increasing without bound, and on this side it's decreasing without bound. But f of negative 2 is undefined. Okay? And we're going to look at some of these same examples in the next section too. So you'll still have your I'm going to pick up here next time, and you'll still have your other recording for the rest of section 11.1. Be sure and watch that. But just really quickly, without me making you take this quiz, let's pull this up here. If x is approaching negative 2 from the right, from bigger numbers, what is f of x approaching? Read the graph. If x is approaching negative 2, although it's not defined at negative 2 at all, what value of y do we always get? Yeah, it's negative 0.5, because here's negative 1. Okay, so it's about negative a half, right? What about if I try to approach 2 from numbers smaller? What does it approach? Negative 1, okay? Do you feel better about, what is it asking me when it wants to know a limit now? Does that make more sense? Okay, well this is another example of that. And what I will do is talk about the existence of limits and finish up a recording for you. So watch the recording that I'm going to post for you before I see you next time on Tuesday. And I'm going to go ahead and post up some recordings for 11.2 and 11.3, the other sections of chapter 11, because I've got some already recorded that I've used before. So get 11.1 done by the time I see you next time. Okay. Is it still going?